Just real quick regarding Ponton Industries. We've been around for 50 years. We specialize in instrumentation and process control equipment. That's flow, level, pressure, valves and regulators, temperature, weighing, VFDs, etc. At the bottom of your screen, there's our main phone number, and then if you ever have any inquiries or have any questions, you can always email into info@pontonind.com, and we've got about 2 to 3 people that monitor that email consistently, so we should have an answer back for you pretty quickly. Also, real quick, just some housekeeping items. Everybody's been muted upon entry. If you do have any questions, please use the Q&A section on the left side, and Mark Lee and I will be monitoring those and answer all the questions at the very end of the presentation. All right. All right, Mark, will you take a second, unmute yourself, and introduce you and your technical consultants?
Sure. My name is Mark Lee, as Josh mentioned. I work directly for the Siemens factory, and I have the pleasure of actually being the technical or the national technical consultants team in the United States. And our team is really kind of a group of industry specialists, application engineers in a variety of different disciplines with respect to different industries, be it water and wastewater, oil and gas, food and beverage, pulp and paper, that type of thing. But we also have what I call the Jedi Masters on all 19 of the product lines within Siemens Process Instruments. And so I wanted to just kind of introduce the team just real quickly, because really where we play, the role that we play is not a commercial role, but a technical role on the front end of a project. When somebody's looking at something and say, how can I, or I'm thinking about, or what do you have that, or our process does this and we'd like to do that, that's really where our team comes into play. We work right alongside the channel partners as really a supplementary technical consultant role for them, but we're also a resource for everybody on the call, for the end users or integrators or contractors of, you know, how can we accomplish that? Josh, if you pop on to the next slide, please. And what we do is we cover all of the products within Siemens Process Instrumentation. So whether that be over on the far left, all things flow, a magnetic flow meter, clamp-on technology, non-contacting technology on the flow, Coriolis meters, vortex meters, those all fall within our umbrella. I'm going to bypass the level for a moment and come back to that in a second, but right there in the middle, we do all things pressure. So whether it's gauge, absolute, differential, DP pressure transmitters, temperature, pneumatic valve positioners, moving over a little further to the right, all things dynamic weighing. So if you have a product that you want to weigh in motion, or you want a solids type flow meter, that falls under our umbrella. We do also basically can point you in the direction of services, so that would be Siemens services such as startup commissioning or field calibration type services. So looping back to the second to the left, which is level, and the reason why I say that for the end is because that's really going to be our topic today. And level really falls into either a contacting or a non-contacting type of technology. So a contacting technology would be something like a guided wave radar or a capacitance, where you actually have a rod or a cable or something that's touching the process. Non-contacting, there's really 2 flavors of that ice cream, where you're going to have a electromagnetic radar or an acoustical, which is a ultrasonic type of signal. Both of those are very similar insofar as they're going to send out some sort of a pulse, and they're going to listen for an echo, and it's basically time of flight. And I know Josh is talking about that, I think, in the next slide. We're going to focus or constrain the discussion today to just the ultrasonic non-contacting level instruments, but recognize that you know, the consultants team that I'm both a member of and the leader of, you know, we cover all of these different product groups, which Ponton does as well. So if you have questions on those, there's my commercial, or my 2-minute commercial for you, Josh. So back to you. Oh, no, I guess I'm sorry.
Yeah.
Still back to me. That's fine. I forgot I had two additional slides here. Within Siemens Process Instruments, kind of a couple of key things that we've added just in the last year or so. There is an Advantage Plus. They all fall under this Advantage Plus program. Advantage Plus shipping basically means that any Siemens instrument, whether you're talking a $300 temperature transmitter or a multi-tens of $1,000 48 or 60-inch mag meter that arrives on a pallet or on a dedicated truck, regardless of the size of the instrument or any instrument within Siemens PI or Process Instruments, the shipping's included. So that's included in the price. I hate to make reference to it, but think of Amazon Prime. Everybody on the call is an Amazon Prime member with regard to Siemens PI, because if you order it, the shipping is included in that, and typically we're using FedEx. Some of the larger areas, some of the larger items might be a dedicated truck, but that shipping is always included, regardless of order size or regardless of product size. The Advantage Plus stock is there are common builds of many of our parts that are sitting on a shelf in the good old US of A. That if you need something fast, this typically is in onesie-twosie quantity, small quantities to either take care of a down situation or take care of a very small project. We do have stock sitting on the shelf for immediate shipment. Sometimes you may need a pressure transmitter and the exact configuration you need isn't available, but we can come back and say, hey, if you can live with this, we can have this shipped out right away. And sometimes that's good enough to get the job done. The support, I did talk about it a little bit in so far as startup and commissioning services, but when you're looking at technical support, you really have kind of a three-legged stool. Your local neck to choke is the channel partner. Ponton are the host of the meeting today. They're really going to be kind of the first local line of defense. And many of the Ponton folks are very, very well trained, especially on the Siemens, the Siemens instruments. Secondarily, you can always reach out to our technical consultant group. And we know a little bit about all of the products that we have, and we're kind of a second leg of the stool. But the third leg of the stool is our technical support phone call. And our technical support line is for all current products. That support call is free. It is USA based, and so you're not calling Germany or you're not calling some foreign country. It is available Monday through Friday, 8 to 5, California time, or basically West Coast time. And we do have support contracts that would allow you for 24/7 support if necessary, but 8 to 5 Monday through Friday, that you don't have to call with a credit card or a PO or a Tech Connect contract or something like that. We support all of our instruments free of charge. And the last piece is that was just added, which is the Advantage Plus warranty. And Josh, if you want to slide to the next slide, our warranty for all Siemens, yeah.
I just want to say that the Advantage Plus shipping and the stock, those are all free services that we offer. You don't need to sign up for anything. The 2-year warranty is standard with our instruments as well. So it's nothing that you have to actually sign up for or pay for.
Yeah, I'm sorry. Yeah, trying to keep it moving along quickly, and I might have glossed over that. And yeah, so all instruments right out of the box have a 2-year warranty assigned to them. So it's 2 years from time of shipping, because we fully recognize that a lot of times instruments get ordered, and of course, as soon as they show up on the job site, they immediately get installed, right? Well, in a perfect world that happens, but in the real world that I live in, that instrument might sit around for a number of months before it actually gets installed, and then the startup may occur sometime after that. So as a result, all Siemens instruments carry a 2-year warranty with them from date of shipment. If you want to extend that warranty to 3, 4, or 5 years, it's basically 2% per year. And it's based on the purchase price of an instrument. So if the purchase price is $100 and you want to extend the warranty for an additional year, it's $2. If you want to go an additional 2 years to 4 years total, that would be $4, and you can do the math, $6 to take it out to 5 years total warranty. If you excuse me, hit the cough switch here. If you want to extend beyond 5 years, it is possible, but that would be something that you'd have to talk to Ponton, and we could get a special price quote on that if you want to go beyond that 5-year window. Typically, 5 years hits 99% of the applications out there. So if you want to go longer, we can, but let's talk about it if it's outside of the standard warranty offering. Now I'll pass it back over to Josh to talk about the Hydroranger, I believe.
Perfect, almost there. So one last thing, today's webinar is being recorded. It'll be on our YouTube channel. So if you go to YouTube, type in Ponton Industries, our channel should pop up. We've got about 5 webinars up there already. One on thermal mass flow, one on remote monitoring for hydrants and PRVs, one on our deragger for deragging pumps. So just some good webinars up there, and this one should be up there by tomorrow morning. All right, so let's get into it. Today's agenda, we're going to go over the basics of the Siemens Hydroranger and ultrasonic level technology. Then we'll get into the Hydroranger 200 versus the newer HMI version. Then we'll talk a little bit about mounting the transducer and which transducer really fits your application the best. And then we'll briefly touch on what PDM software can do and how it can help with the Hydrangers. In the future, so we're looking at maybe hopefully July 2020. We're going to do a course 202. We'll get more into deeper dive into the Hydroranger and get in more into like a reading echo profile, talking about how to perform an auto pulse echo suppression, what the algorithms mean, when do I need to have a sync function active, and then also how do I read my confidence and signal strength, and then also get into a little bit of troubleshooting. All right, so what is it? What is a Hydroranger? So the Hydroranger is, when coupled with an ultrasonic transducer, is an ultrasonic non-contacting level controller and transmitter. It was originally introduced by Miltronics in the late 1980s, and then Siemens acquired Miltronics in 2000 and has been developing the Hydroranger ever since. There's currently about 300,000 units in the United States alone. I believe we mentioned there's about 1 million throughout the world currently. Most of what you see today is the Hydroranger in the middle. There's still a couple of the Hydroranger Plus, Multi-Ranger Plus out there, but the one in the middle is what we see most often out there. It's programmed with a handheld remote, and then recently, within let's say last 5 years, the HMI version, which is the Hydroranger on the right, with the 4 push buttons, has been introduced, and it's made it a little bit easier for us. So when it comes to the Hydroranger, it comes in a 1, a 3, or 6 relay model. It has the ability to take in 1 or transducers, and it all depends on the model. All right, so what can the Hydroranger do? So basically, a Hydroranger, its basic form, can do ultrasonic level measurement. But at the same time, we can also do open channel flow measuring with Flume or Weir. We can do a volume calculation with the Hydroranger. We have the 6 relays, so we have the ability to have pump control and alarms. Specifically for pump control, we've got fixed duty assist and alternate duty assist algorithms built into the Hydroranger, the 6 relay model. Then we also have the ability for bar screen and differential control when you're in channel, and it kicks on a relay when the differential reaches a certain height. Then a lot of people also forget about that the Hydroranger can also take in a milliamp input. So for example, if you have a lift station and the ultrasonic sensor's not giving you what you need, not performing correctly, you could possibly run a submersible pressure transducer or a radar transmitter into the Hydroranger 200 into a milliamp input and use that as your control. You can have your ability to have your relays, your display, and everything on there using the Hydroranger. You would need a little power supply there for it, but it's possible. So how does ultrasonic level technology work? So the Hydroranger, when it's coupled up, paired up with the ultrasonic transducer, so in terms of Siemens, you know it as the XPS-10, XPS-15, XRS-5, or an STH. What we're doing is the transducer is sending out a sonic pulse. It records the time of flight, so it shoots down, hits the media, and then receives the signal. So basically, it's acting as a speaker and then a receiver. All right, so with that, with the past example, so we know that distance equals velocity times time. So with our last example, we shot down, hit our media, and its time was 58.2 milliseconds. And then with the speed of sound at 68 degrees Fahrenheit, we know that it's 1,128 feet per second. So we can use that calculation to come up with our distance, which is calculated at 65.6 feet. But we're only trying to measure the distance to the media and not the distance to the media and back. So we got to divide by 2, and that gives us our 32.8 feet. So that's kind of how our distance is calculated using ultrasonic and with the time of flight. So in an ideal situation, you have a tank, you have no obstructions, you've got a clear path for the transducer signal, echo. If you can look on the left, this is what we call an echo profile. So basically your transducer is sending a signal down, it's getting an echo off of the water, that's what you can see over there, and then you have no obstructions, and it's a beautiful signal. But in real life situations, we've got pipes, ladders, beams, wires, fill pipes, everything just to cause problems with our ultrasonic. So with this echo profile, so you can see as the sensor sends a signal down, we've got a little bit of an echo off of our fill pipe, and then we've got a larger echo off of our water. So it's always important to take into consideration the mounting of your transducer when using an ultrasonic transducer in this kind of application. If you don't have the ability to move around these or to mount the transducer in a certain area, we do have ways to work around it using our sonic intelligence and auto pulse echo suppression, those kind of things. So I'm going to turn it back over to Mark, and he's going to talk a little bit more about our sonic intelligence.
Yeah, with sonic intelligence, that really is kind of the sequence of events of how a measurement takes place. And it really takes place in about 7 steps. And so the ultrasonic controller is going to send out a pulse, and then that pulse is going to go ahead and just advance through it there, Josh. That pulse is actually going to reflect off the material, and you're going to get a return signal. And that return signal, there we go. That return signal, it measures that time of flight, and like Josh says, rate times time equals distance, but distance divided by 2 because it's down and back, and that will give you a very accurate distance to the material itself. The next thing it's going to do is form the echo profile over on the right-hand side, which is that blue line where you're going to see basically it drops down to the noise floor, and then at some distance you're going to get an echo off of the material itself. After that, it applies some filtering, and there's a couple of filters called a spike filter and a narrow echo filter to take out some of the noise from there. Then it's going to form the TVT, which is called the time varying threshold. That's the red line that's represented on the chart over on the right. Basically what that TVT does is it helps to select out areas where maybe you're getting false reflections or some noise. So essentially any echoes that extend to the right of the TVT line in this picture could be considered valid echoes. You can see in this particular example there's only one valid echo. In the real world, sometimes with pipes and obstructions and weld seams and concrete seams and stuff, you may have a number of echoes there, and you have to deal with some of the stuff that will be handled in the 202 class that Josh was talking about, which is maybe some advanced manipulation of that time varying threshold. The thing that's unique here with Siemens, though, is that TVT is dynamic, meaning it is recalculated each and every time the instrument makes a measurement. That's a key differentiator between Siemens instruments and others that are out there, because if you have a fixed signal reference line, say that one 3 times fast, what can happen is if you have changing process conditions such as turbulence or some sort of change in the process or obstructions, a fixed signal reference line doesn't always give you a true representation of what's happening in the process because your process is dynamic. The fact that that TVT is calculated each and every time is the key differentiator in the thing that we call process intelligence. Then the instrument is going to apply something called echo algorithms in step number 6. Those can be user-defined based on different types of applications beyond the scope of this discussion today. And then finally, it's going to make that echo selection. Depending on the application, it may be performing these 7 steps several times a second, but it goes through these steps each and every time it makes the measurement in order to select what the instrument believes the true echo to be, and it takes a lot of calculation in there to try and filter out the false echoes that you may get from the real world that I live in, which is, you know, a dynamic process. So, next slide.
All right, back to me. Okay, so now that we know how the ultrasonic works, how the technology works, let's talk a little bit about the basic information that you need in order to set up a Hydroranger in the field. So I like to consider it as there's 7 questions that you need in order to set up a Hydroranger 200 for a basic level application. With the standard Hydroranger 200, the one that uses the push-button remote, everybody knows it as P001 through P007. So this one is parameter-driven. Got to pull up the manual and look up your quick start and see what P001 and P007 mean. So for example, you're always going to have to answer what operation. Are you doing level, are you doing distance, or are you doing space? So most common with us is we're going to be doing level application. So you take your handheld remote, put a 1 in there, and then move on to number 2, which is material. Are you doing liquid, or are you doing a solid? Number 3, process speed. Medium is the most common right now. Put a 2 in there. And then number 4, you have a transducer. It has ability for all the Siemens transducers, so XPS 10, 15, etc. P005, what units? Feet, inches, meters, millimeters. Then the 2 probably most important parameters that we need to enter is your empty distance, which is your distance from the transducer phase to your 0. And then P007 is your span, so whatever you'd want your 20 milliamp to be set to. I'd like to say that with P006, with your empty, the X, so your level is basically inferred by the distance. So with P006, the more accurate you can get with your empty distance, the more accurate your level is going to be on the Hydroranger. So that was P001 with P007. That was the standard Hydroranger with a push button. Everything's parameter driven, but with the new HMI Hydroranger 200, everything is quick start driven. So you'd hit your right arrow to go into the menu structure, and then you have options for quick start. And then quick start level basically walks you through setting up an application for level. So instead of having to know what P001 is, it will tell you what's your operation, and I just select level. Very, very easy, especially when you're doing open channel flow. It walks you through open channel flow. You don't need to figure out what parameter it is. And then also setting up your relays with the new HMI is much easier compared to the other standard Hydroranger. So just something to consider. So I mentioned that it's much more intuitive, local interface. It's 4 buttons. Everything's menu driven. The quick start makes it real simple to get a Hydroranger up and running in a matter of minutes. The wiring compartment is isolated. Siemens made the terminal blocks removable, so easy wiring. Everything's numbered. Pretty simple installation. And what I like the most is that it fits the existing Hydroranger 200 enclosure. So this is a picture of the inside of the Hydroranger. Removable terminal blocks. Everything's labeled. Everything's numbered. Pretty simple. And then for retrofit, so if you have the older standard Hydroranger 200 out there, and let's say one of them fails, you could take the guts out of the older style Hydroranger. Say there's 4 screws, pull those out, and then put the guts of the HMI version into the older enclosure of the Hydroranger 200, and be up and running. So that way you don't have to cut new holes into the enclosure, the back panel. You just change out the door on there, and you're up and running. It takes a matter of minutes to get it up and running. One thing you need to remember though is that when you do switch out the older style Hydroranger for the new HMI, the serial number is not going to match up with the enclosure. So if you're calling in for a warranty purpose or to get a new one, remember that the serial number is on the board and not on the enclosure. So this is the basic display of the new Hydroranger. You got your reading type, your level, all your relay status at the bottom. Your 0 to 100% scale on the right of this secondary screen. So that's the main screen, but if you hit the bottom key and go down to the secondary screen, it comes up like this. You've got your main reading, and then you have an auxiliary reading at the bottom. And if you hit the left arrow key when you're on this screen, you can cycle through all of the different auxiliary readings. So you can see your milliamp output at the same time as your level. You can also see your distance measurements. So what this allows, it allows for an easy way to troubleshoot and basically confirm that the Hydroranger is working properly. Another nice feature with the new HMI version is that you can see the echo profile on the display of the HMI version, whereas with the other standard version, you have to actually use the PDM software in your laptop in order to see the echo profile. But if you go down to if you go into the menu structure and go to maintenance diagnostics and then hit echo profile, it'll take a snapshot of the process as it sees it. It'll give you your confidence reading, your algorithm, and then also your distance at the top. And then you can also see if there's any obstructions or anything that you need to map out. So a really helpful and easy to use troubleshooting tool with the new HMI version. Another thing too that is with all Siemens equipment that's going out now, there is a QR code. With the Hydroranger, the QR code is on the top. All you got to do is pull open your phone, turn it on the camera, point it towards the QR code, and a little pop-up will come up, and that will guide you directly to the manual. It'll guide you to any certificates or anything that's associated with the serial number on that unit. All right, so let's get into transducers. All right, so with Siemens, we have about 5 transducers that work with the Hydroranger 200. They're all different lengths, different feet, and they're all kind of specialized for certain applications. Where, let's say the XRS5 is our small little guy right here, and this is more optimized for open channel flow, high accuracy applications, and where then the STH is material PVDF or ETFE, so those chemical totes, chemical tanks, anything along those lines. It's got a 2-inch NPT connection on the bottom, or you can use a standard 1-inch NPT connection on top. Then we have our probably the most common transducers out there are the XPS10, the 15, and then there's the 15F, which is our Class 1 Div 1 rated transducer. If, in terms of performance, if you wanted to just stock one transducer, I'd suggest stocking the XTS 15 over the 10. The 15 is going to be a little bit more money, but it's got better performance and can do everything that the 10 can do better. It's also got a 6-degree beam angle over the 12 from the XTS 10. All the units have a 1-inch process connection, or you can also get them with a flange connection as well. All right, Mark, you want to take this one, beam angle?
Sure, throw that one to me. Actually, beam angle, yeah, is one of the most misunderstood pieces with regard to both ultrasonic transducers and radars. And really kind of to dispel some of the myth or the mystery of that, if you go to the true definition of what a beam angle is, and this goes back to the days of radio communication, beam angle from an antenna or a source is defined as twice the angle at which the off-axis measurement is 3 dB less than or half the power of the center spot. So in English, really what that means is that your strongest signal is going to be right down the center line of your transmission axis. And so that's shown on this drawing at the 100%. Okay. Somewhere way off in the distance, there's going to be a 0% where there's no longer any energy that could be recorded that's being transmitted from your transmission source, in this case, an ultrasonic transducer. Well, halfway between, from a signal strength standpoint, the 100% strongest point and the 0% weakest point, you're going to have a 50% or a 3 dB point where it's, you know, half the power. Now, that isn't necessarily 50% of the distance between the 100% and the 0%. It's 50% of the transmitted power, okay? And so what you have is beam angle is both sides, or the total angle that includes both sides of the center axis, and it's that measurement to the 3 dB boundary. So what you find is that when you're comparing a 12-degree or a 6-degree, a 6-degree beam angle really means that there's 3 degrees on either side of that center axis. You have to be a little careful in the spec sheets, because when you're comparing from manufacturer to manufacturer, you'll find that some of them cheat and only use 1/2 of the beam angle, which is from the center line to that outer edge on one side, and so then they claim these really ridiculous beam angles. And so if you are going by the true definition, it is the angle on both sides. Here's the key takeaway from this. It doesn't mean that once you get outside the beam angle, there's no energy. In fact, 50% of the energy is still outside of that beam and can cause reflections. So if you do the trigonometry on this and you take the tangent of the angle times the distance and you calculate the spot size and whatnot, that is where your 50% point is. If you have an obstruction that's just outside of that, likely you will get a reflection off of that. But it's a way to kind of contrast and compare between performance of different antennas. Here's the nugget. There's something that we use called the 10-to-1 rule, which is kind of a rule of thumb that I use just for kind of back of an envelope calculation if the system will work, which is for every 10 feet down that you're coming from the transmitter, I'm looking for a transmission source that's about 1 foot off of a sidewall. So if I'm looking down a wet well, and that wet well is about 25 feet deep, I'm looking for to place that transducer about 2.5 feet, or 1/10 of the distance that I'm trying to measure. And generally speaking, in that case, if I have about a 2.5-foot radius or about a 5-foot diameter circle without a lot of obstructions in it, that's really going to be a good solid installation where we're going to have good performance. A lot of people try and use these beam angles as a hard and fast rule and say, the beam angle says 6 degrees, so therefore something that's 7 degrees out, I won't see it. Now you probably will. And so you have to be a little careful, but it's a way to kind of compare between a couple different, if you're comparing antennas and what's going to work. And that 10-to-1 rule works really, really well, whether you're talking 15 degrees or 6 degrees or 4 degrees. That 10-to-1 rule has really never really let me down. So beam angle is something you can get really mathy and real precise with it, but it's just really a number that's being used to compare, and you have to be a little careful in applications where you're really close to that beam angle. So, next slide.
This is kind of going to demonstrate.
Yeah, that's showing an application with some obstructions. I'm sorry, I didn't know that animation was there. So you want to place the transducer at the place where you're going to have the best view using that 10-to-1 rule to be able to see down to whatever your 0 point is in the process. So, sorry, I forgot that animation was there. There we go.
Now I'll go into some mounting considerations. So just for the transducer purposes, on this tank we have 4 different locations, and then in this tank you got a ladder, you got your fill pipe, you've got your tank supports. So obstructions are out there. So with mounting consideration number 1, say you're too close to the wall, you might catch on to the ladder. As your level decreases, you might have a false reading that is the ladder, and it might stick at a certain level, and that's going to cause problems over time. If that does happen, we do have the ability to do some mapping out with auto false cycle suppression, and we could possibly get that up and running. With number 2, though, installation number 2, 1/3 the distance from the sidewall. There's no obstructions. You should have no issues with getting a accurate reading and a solid signal strength coming back to the transducer itself. And number 3, this one would not be a good mounting area on a parabolic tank. You'd get a good return off your liquid, your water, but then you'd also have problems with secondary echoes. It would bounce off the top of the parabolic tank, and then come back down, hit your media again, and then reflect back into the transducer, causing secondary echoes maybe 2 or 3 times down the road, and sometimes could be have a higher signal strength than your actual level and your actual media. And then for mounting consideration number 4, when there's no flow coming into the tank, probably have a good reading, probably have a solid signal back, but as soon as you have water coming in, you're going to lose signal and they have a high reading. Also, another thing to consider is with the ultrasonic transducer, you want it to be perpendicular with the surface that you're monitoring. So with liquids, with wavy kind of turbulent, like lift stations or anything, you want to have it pretty much perpendicular, pretty much flat, shooting straight directly down at the media in order to give you the best signal return coming back to the transducer. If you have a solids application using ultrasonic, you want to have it pointed at the angle of repose. So then if there are any obstructions in there, we can use auto false cycle suppression, where we map out the ladder or the rungs or anything along those lines. Another thing to keep in mind is you can also use an ultrasonic transducer with a stilling well. We would recommend one long piece of pipe. We wouldn't want the bottom of the transducer or the bottom of the stilling well to become exposed either. And we want one long piece of pipe, because if there's seams in there on the stilling well, it could cause a false echo. Your reading could get stuck at that one seam. We could form an auto false echo suppression with that, but easier to just have one long run of pipe to the stilling well. Another thing to keep in mind for a stilling well, you want to have a little vent on there to keep the pressures equalized. You don't want it to get too pressurized and then throw off your reading in the stilling well. And also, one thing to keep in mind too is that on the transducer with the coupling, when you're mounting it with that 1-inch MPT, you want it to be hand tight. You don't want it to be too tight on there, and it would cause excessive ringing and probably give you some lower signal strength coming back to the transducer itself. Also, with the transducer, just keep in mind with all ultrasonics that there is about a 1 foot blanking distance from the transducer face down a little bit. So 1 foot from the transducer face, this transducer can't see anything. All right, I'm going to touch base real quick on PDM software. So PDM software, this is a program provided by Siemens. It's a $120, $130 per license software, and it allows you to access the Hydroranger 200 using your laptop or computer using the Modbus port on the Hydroranger. Where this comes into play and is really useful is with those older style Hydrorangers where it's parameter driven. You can actually connect to it with your laptop and then download the parameters from the Hydroranger onto your laptop, make any changes you need to make, and then re-download into the Hydroranger. So that way you don't have to pull up a manual in order to make any changes. It also gives you access to see the echo profile in the older style Hydrorangers as well, where with a new HMI you can see it on the screen, but on the older style you gotta have PDM software in order to see what's going on and take a snapshot. Another thing that PDM software can do is it allows you to get all the parameters from the Hydroranger and put them into a PDF, print them out, put them next to the Hydroranger, so that way you have a record of all your parameters in that Hydroranger. Some of these Hydrorangers have readings for relays or for pump control that are difficult to remember. So this gives you the ability to print everything out, put a copy right there, and have a record of it. You can also save a copy of the parameters onto your laptop. So let's say you have a older style Hydroranger and it fails and you want to replace it with a new HMI version. You install it, hook up to it with PDM software, and then you find that file from the Hydroranger that failed, hit upload, and you can have all those parameters downloaded into that new Hydroranger. So you don't need to do any programming. You just hit the download button, and then you're back up and running. Pretty simple, easy way to do it, and easy to just keep all your Hydrorangers in one place. All right, so just real quick, why the Hydroranger? Easy installation, easy to use, especially with the new HMI version. The transducers are self-cleaning. The speed of response for ultrasonics is extremely quick, and then you have your local control back to the PLC. There's 300,000 of these throughout the United States, so it's proven and trusted. It's great. It's been around for over 30 years so far, so it's a well-tested and well-trusted device. Siemens has unparalleled sonic intelligence echo processing that puts it a step above. The 2-year standard warranty is also a great offering, and it's just a nice instrument to stock. It does multiple things, very versatile Siemens instrument for ultrasonic level. So I'm going to go through the questions real quick, and I'm going to have Mark take a look, or Mark answer some of these. All right.
I took the liberty of typing in a few answers there, so.
Okay. So, but then there's one here that says, so you can connect other 420 devices to a Hydroranger instead of just the EchoMax transducer. And that's true. Yes, you can take any 420 milliamp device and run it back to the Hydroranger and use it as a display. You'll span it, your 420 milliamps, and use that as your control. You would need a little power supply in order to power the other.
Sometimes it depends on the device. Yeah, it depends on the device. It can loop power some devices, depending on the device itself. Sometimes an external power supply is required to provide enough current for the loop itself, but it can provide power to loop power devices directly from the Hydroranger without an external power supply. And without knowing what device we're talking about, it'd be hard to define, it'll do this one but won't do that one. I mean, we could look at those on a case-by-case basis.
Mm-hmm. So using the transducer in a relatively narrow pipe, how does the Hydroranger deal with false echoes?
I think And yeah, that's the one with the preventing weeds from obstructing the signal. You know, if you have something that's growing inside of the pipe, you know, we can't really control how things grow and how they might obstruct over time. But when you look at the echo profile will give you a relative measurement of signal strength. And if you look at that echo profile using either the display screen of the Hydroranger HMI or PDM, you can see how that echo profile changes over time. What a lot of end users do is they use PDM as a way to document their system. So they will go out and today my Hydroranger in this application is healthy and it's working well. And they do two things. Number one is they use PDM to do an upload of all of the parameters that are within the Hydroranger 200 and convert that to a PDF document that you can now either print out or save electronically. And they also do an echo profile, which is, here is what the echo profile looks like today when my system is operating at 100% efficiency, or it's operating properly. 6 months from now, I have a problem with that particular well or stilling well or narrow pipe in this case. And if you go back out and connect up PDM to it, you now can take a snapshot and you can look at the parameters and say, has any of the parameters changed? You know, has somebody come in and messed with it? Right? But then you also have a baseline on that echo profile, and you can say, here's my echo profile today, here's what it was 6 months ago, and now you have kind of a baseline to compare. It was working here, it's not working here, what changed? Well, my signal strength is half of what it was 6 months ago. Why is that? Oh, well, look, there's something growing in here. So that echo profile really can give you a indication if you keep record of it. I get it all the time where people go out and they document their system by using an iPhone, and they get the echo profile on the display screen and they snap a picture. Now they have a date and time stamp with an echo profile of what it looked like at a particular time, and they can come back later on and do that. So, you know, I can't control how things grow and how they might obstruct. Yeah, you get enough material in the way, it'll block the signal, right? But how much it's blocking over time, that's something that you can measure, but you have to get a baseline or a measurement point to start from. Long answer to a simple question, but I thought it was a good way to really kind of highlight, you know, PDM or documenting your system. You know it's working here, it's not working there, what changed? If you have a baseline to work with, you can see that. So, anything you want to add to that, Josh?
All right. No, that's good. Can you real quick compare the probe versus the Hydroranger?
Sorry, I bumped my mute button there. The probe versus the Hydroranger. Question is, if we're talking the probe or the probe LU or the new replacement for the probe LU, which is the LU240, I'm not sure which one we are comparing. The probe is a fairly dated technology, and it is good in some real short applications. It's a real simple device, but electronically it is, you know, think of a laptop 10 years ago versus a laptop today. You know, not a lot of, there hasn't been a lot of improvement on that. The probe LU really replaced the probe. The probe was actually that unit that actually had an angled head on it. The probe LU was a significant upgrade, and really was kind of a scaled down version of the Hydroranger, has a subset of the parameters that the Hydroranger has. It is both the probe and the probe LU are loop power devices, as opposed to the Hydroranger, which can be which is a powered unit. The probe has fewer parameters, and in simple applications works really well. Probably a topic for another day would be the LU240, which is the newest released in 2019 replacement of the probe LU and the probe. And think of a laptop today versus 10 years ago. It has the latest, greatest processor in it, has some memory built into it. And the one thing that I did find on that is I did a side-by-side comparison between the probe and the probe LU and the new LU240. And although the process connection and the transducer looks the same on the outside, there is a considerably upgraded crystal in the LU240, and the signal strength is about a third more, about 30% greater. And so with that, you get a much, much better echo profile. I did a side-by-side comparison in my home office. I could tell the difference between my my ceiling in my media room, which is a smooth sheetrock ceiling, and when I moved into my office, there's actually a popcorn ceiling. And with the LU240, I could actually see the difference on the popcorn ceiling because there's just a much, much better processor in that. So if you need something that's just a real simple level device that's loop powered with a scaled down series of parameters, because you're not doing a lot of advanced control, you're not doing pump control or anything like that, the LU240 or the Probe LU is a great fit for those applications. The new LU240, for example, is a great standalone unit if you want to put it on a pallet tote or even a 55-gallon drum. That's a great place for that device. Doesn't have a lot of bells and whistles, but has some functionality for simple level applications. So maybe went a little deep on that one, but you know, side-by-side comparison, all-in-one versus one with an external transducer, an external transducer and instrument. The Hydroranger does have external relays, whereas the other devices do not. Josh, you want to add anything to that?
Talk about just that the display on the Hydroranger is remote, where the Probe LU and the LU240, it's all at the process itself.
Yeah, that's true too. If you stick it on the top of a 30-foot high tank, you can't see the display unless you climb up there. Where the Hydroranger, you could have it at ground level. Good point.
Correct. Can you talk about the XPS30 as an option to replace radar and lasers for extended range applications?
Well, extended range would be what, what does extended range mean? The one thing that you will find is that, I'm sorry, it was lasers, and I don't see the question here.
Radar and lasers.
Okay, I didn't see it. Okay, radar and lasers. Typically speaking, when you get to longer ranges, radar does extend out quite a bit further. You can get upwards of hundreds of feet with radar, where ultrasonic just carrying the acoustical signal that far, you really can't. Lasers do have one of the challenges, especially if you have an environment where you do have even mist or clouds or some sort of physical obstruction where it's going to disperse. You're going to have dispersion of the laser. That can be a real challenge in those type of environments. Laser in theory can go further. I mean, they bounce lasers off the moon, right? But you need a real clear path between that, and any kind of clouds or even humidity in the air can disperse that laser and can cause some challenges. So, radar probably has the ability in most level applications to go a little bit further, but the XPS30 does give us some, pretty good distance to go with as well, and probably would be available for most of the tanks and silos that I run into. Maybe not a 200-foot high grain silo, but you can get half that.
All right.
Great questions. Great questions. Yeah.
Can the Hydroranger be used in pressurized vessel or only atmospheric? I know this is one of your favorite questions.
Oh, I love that question. Yeah. So, anybody remember the movie from the late '70s, the movie Alien, with Sigourney Weaver and I think it was late '70s, early '80s. The tagline for that movie when it was in the theater was, "In space, nobody can hear you scream." Okay, an acoustical sensor or an acoustical device such as a Hydroranger, it is a compression wave and it needs a media to push against. So in other words, in a true vacuum, in space, nobody can hear the transducer scream because there's nothing for that signal to push against. The other flip side of that is in a pressurized vessel, if you imagine if we go out into the parking lot and or in my driveway because I'm working from home, and if you go out to the speaker in my car and you put your thumb on the speaker, what happens to the sound quality? The sound quality gets significantly attenuated and diminished. Okay, if you're in a pressurized vessel, the face of that transducer is effectively a speaker. It physically has to move. And if you pressurize on the face of that transducer, you could impede and or attenuate, and to a certain point, at a certain point, just completely block the signal because that transducer face can't move. So generally speaking, we say, yes, the transducer can only be used in atmospheric. You can get a little bit above atmospheric pressure, but not much, because you start to put your thumb on the speaker if it's a pressurized vessel. That's really a better application if it's pressurized for radar or guided wave radar applications. Great question. Love it.
All right, there's a question here. It says Pointec versus the Hydroranger. So Pointec is going to be more of your single point level reading, whereas a Hydroranger is going to provide you with a continuous level reading through your whole process with the ability to have your relays at certain points and your high alarms and your low alarms at certain points. Anything else you want to add to that, Mark?
Yeah, I would say why not both? In any level application, a point level measurement really is critical to have a critical high or low, especially if it's something where you have an overflow condition. And generally you want to use a different technology for your safety system than you do for your main measurement. A point tech is only going to be a contact closure or a relay closure to say, I have reached a level, pick a number, at 10 feet, right? And so it's only going to give you an indication when you get there. The Hydroranger is going to give you an analog measure, so I can see I'm at 6 feet, 6.5 feet, 7 feet, 8 feet, 9 feet, and so on. So you have that continuous measurement using the Hydroranger, but solid engineering practices really mandate or dictate that if you have a continuous level device, solid engineering practices dictate or mandate that you have a point level device as a critical high. Anybody wants to research what can happen when you don't have that, just Google search BP Texas City explosion, as a refinery blew up in Texas City, what is this, 15, maybe 20 years ago now? And really the key failure point was they had a continuous level device, happens to not be a Siemens device, that's why I can tell the story, but there was no high point level device to indicate that the continuous level device had failed. They overflowed a tank. They thought they were at 15 feet, and at 98 feet of level, they overflowed a vessel, and it vented to a blowdown drum and led to an explosion that killed 15 people. So Pointec versus Hydroranger, yeah, they both be used for level indication. My suggestion, if the application is critical, use both.
All right. And the length of the transducer cable, if we cut it shorter, that does not affect the measurement, correct?
Nope. You can shorten the cable to any length you want. The cable can actually also, the factory cable can be extended, and there is a section in the manual for how to do that properly. Do not, capital not, double underline, use yellow wire nuts as your connection to a shielded twisted pair, such as a Belden 8760 if you're extending. Shortening the cable, cut it as short as you want. Just be sure to not cut it too short because it doesn't stretch very well.
All right. If the tank becomes full of liquid, does the radar need to be dried off? Let's make it radar and ultrasonic. Does it need to be dried off before putting back into service?
Okay. If the tank becomes full of liquid, does the radar need to be dried off before returning to service? So yeah, question. If we're talking a radar application, the radar has a basically an emitter, and if you get liquid actually on the emitter, your performance is going to be significantly degraded you know, if you have gotten liquid on that, or water droplets, or even condensation. Depending on the unit, and if the unit's sealed, it may just be, if it's just something on a radar where it's a sealed unit and it gets on the face of it, no. If it's an open horn and the emitter has become contaminated, the answer is yes. In the case of ultrasonic, kind of extending that, the ultrasonic, because it's a speaker and it's an active face, there is a tendency for that to kind of flick water off of the transducer face. One thing that can aid in that is if you, an undocumented field solution is to actually put like Rain-X, or I've seen car wax used on the face of the transducer, helps to bead up some condensation. And so as the transducer fires and that face flexes, it can actually flick the water right off. And so that can be less of a problem. If you completely contaminate it with mud, or it gets covered in cement, yeah, you probably have to take it off and clean it off before it could be used again in an ultrasonic. So,
what about a solution to spiders, Mark?
Solution to spiders. For some crazy reason, spiders love to live in the environment where the that 44 kilohertz. Either it doesn't bother them, or it almost seems like the spiders just love that environment. An XPS-15 transducer is putting out about 100 to 125 dB of sound, so it's right up there in the rock concert to jet engine range as far as acoustical sound that it's putting out, and spiders just love to live right in the transmission cone. Don't ask me why. Spiders' nests, to the most part, are transparent to the acoustical signal, but I have seen applications, especially like in a constrained pipe or a stilling well, where there's been so much spiders and spider debris from, let's call it the leftovers from what the spiders consume, that there's enough of a nest there that it could start to impact or impede the signal. Why they like it so much, I don't know. If it becomes an issue, you know, yeah, you have to clean it out. Watch out for black widows in Southern California, I have found.
Mm-hmm. I think that's pretty much it. I'll go back through these questions, and if we did miss any, I'll respond to them directly. And I think that's going to conclude our 1-hour presentation today. Appreciate everybody for jumping on. Mark, thanks for helping out. And if you have any questions, yeah, feel free to reach out to me. Yeah, feel free to reach out to me on my email address or general inbox. And then Mark's phone number is there too, and Mark's always here to help as well.
Yeah, reach out. I mean, Ponton's a solid organization. They've got some great experts on site. If you send me an email or reach out to me, unless you put an email, do not tell Josh. I just copy Josh in on the response anyway, so he knows what we're talking about. But it's never had anybody do that, Josh. I don't know why. I don't know what's up with that. But you know, certainly, you know, Ponton is a great resource for questions, and you know, if they don't know, you know, they're not afraid to reach out to myself or anybody else on the consultants team. So, you know, excellent.
And we'll get 202
excellent questions.
For next month. Awesome.
Yeah.
All right. Thanks, everyone.
You bet.
Thanks, Mark. Bye.